All right, so how do we deal with strong acid solutions? And what we're going to do is I'm actually going to introduce that there are going to be 5 different cases in which we're going to have to know how to calculate the pH of an acid or a base solution. And we're going to see that those 5 on the next slide. But I'm going to start with saying it's absolutely critical that you know what those strong acids are and what the strong bases are. Because our ability to know whether we have a strong acid or a weak acid or a strong base or a weak base is solely tied to the fact that we know that list. So for instance, when we're dealing with acids, if we want to know if an acid is a strong acid, we're going to look at that list. Okay? If the acid is one of the strong acids, then we're going to be able to directly find the pH very, very simply. If it's a weak acid, not going to be nearly as simple. So it's very important that you can determine or be able to figure out what's a strong or a weak acid or a strong or a weak base. And it's the same way with a base. If a base is a strong base, all right, if it's on that list, if it's got the hydroxide ion in it, then it's a strong base. We can then figure out, all right, figure out what the pH of that solution would be fairly directly. In the case of a base, we're going to find the pOH first, and then we're going to use the pOH to figure out what the pH is. And we learned how to do that in one of the previous videos. So the 5 cases that we're going to look at are going to be that we were going to have to know how to determine the pH of will be when we have a solution of strong acid. We know we have a solution of strong acid. What's the pH of that solution of strong acid? When we have a solution of strong base, what's the pH of that solution of strong base? When we have a weak acid, or when we have a weak base, or when we have something called a buffer, and I'm going to tell you the buffer is probably going to wait. We're not even going to get to it probably this week. So the buffer is coming, but we're going to probably look at that come next week. Now, for strong acids and base solutions, number 1, we have to find out what the concentration of the strong acid or the strong base will be. In most cases, we're going to be given what that is. All right, so you're going to be told, oh, you have a pH, what's the pH of a solution of 0.1 molar hydrochloric acid? So we're going to have to take that concentration of the strong acid or the strong base, convert that to concentration of H plus or OH minus. I'm going to show you how to do that. And then calculate the pH or the pOH from that solution. There's no equilibrium involved here. It's stoichiometry only. All right? If we have a base and we calculate pOH, then we have to say pH plus pOH equals 14 and figure out what the pH would be. So we're just more or less going to work through a couple of these examples. I feel like it's so much easier to work through the problem than it is for me to try to describe it in a lot of words. Okay? And so in this case, we have a 0.1 molar solution of hydroxide or of hydrochloric acid. So we have 0.1 molar hydrochloric acid. So remember, hydrochloric acid is going to donate its protons, HCl. Remember, we show a single arrow because it's one of the strong acids. It's on that list. Produces H plus and Cl minus, and we said that happens in stoichiometric amounts. So in this case, we're starting with 0.1 molar hydrochloric acid, which is the same as saying 0.1 mole of hydrochloric acid per liter of solution. And we know that 1 mole of hydrochloric acid produces 1 mole of H plus. And if we're trying to calculate pH, H plus is incredibly important, and its concentration is incredibly important. So those moles cross out, we're left with 0.1 molar H plus. Notice, the concentration of the strong acid tells us the concentration of H plus. From here, it's straightforward. The pH is the minus log of the concentration of H plus. We know the concentration of H plus is 0.1 molar, so the pH is minus the log of 0.1. pH is equal to the minus of the log of minus 0.1 is minus 1, and the pH equals 1. Does that make sense? We have a pH that's very much below 7. All right? Solutions that have a pH below 7, we refer to those as acidic. This is highly acidic. Would we expect a strong acid solution to be highly acidic? We would. pH of 1 makes sense. It fits with what we think it should be. And so that's very likely, if you were doing the problem on your own, you could have a high degree of confidence in saying, okay, I did something right here. Next, we're going to talk about how do we do the same thing but with a solution of base instead. And we're going to work through the same scenario with the same procedure that we worked through before. We're going to say, okay, we have a 0.1 molar solution of sodium hydroxide. What happens to sodium hydroxide in solution? It produces sodium ions and hydroxide ions. And I made a mistake here. So don't make this mistake whenever you're doing this. This is not an equilibrium. It is a line, a straight arrow, okay? Just one single arrow because it's stoichiometric. 1 mole of sodium hydroxide in solution gives us 1 mole of hydroxide. So if we have a 0.1 molar solution of sodium hydroxide, that's 0.1 mole of sodium hydroxide per liter. And we know 1 mole of sodium hydroxide produces 1 mole of hydroxide ion. So 0.1 molar OH minus. Same thing. Now we want to determine what the pH is, but for a base we have to go through pOH first. We say the pOH equals the minus log of the concentration of hydroxide ion, 0.1 molar. The pOH is minus log of 0.1. The pOH equals minus a minus 1. The pOH equals 1. And then remember we said the pH plus the pOH equals 13. So now we have the pOH is 1, so the pH plus 1 doesn't equal 13, equals 14. I'm sorry, I'm making all sorts of mistakes with this. We said the pH plus the pOH equals 14, not 13. So pH plus 1 equals 14. Sorry, I've got the answer already in my head. And the pH is equal to 13. Now, does this make sense? We said that a pH above 7 or greater than 7 is what we call basic. If we have a concentration of a strong base, we would expect that to be very basic, so a pH of 13 makes complete sense. That's how we might work through or determine what the pH of a strong acid or a strong base solution would be. We'll look at weak acids and weak bases in the next video.